This video will look at calculating the correlation coefficient for a simple example. Example 1. Study was conducted to determine if for a certain remote tribe there is a relationship between the number of siblings a woman has and the number of children she has. The data are shown. So in the top row we have siblings, and I declared that X as our independent variable, and in the bottom we have the number of children she has, our Y variable, our dependent variable. Now the important thing to realize about correlation calculations is the math works the same either way. So if you had come to the opposite conclusion for some reason, the math would still work. All right, typically when you're looking for correlation, one of the first things you want to do is check the scatter plot. So here you see the scatter plot that I did with the XY scatter plot feature in Excel. And if you look at this, there is somewhat of a line going through that. And that's really what the correlation coefficient is looking for, is do we have a relationship that we can identify. Now, thing to realize, and it's called out here in the notes, the range for the correlation coefficient is from -1 to +1. All right, we're going to go and look at the formula. The formula looks fairly complex. There's a lot of notation there, but it actually breaks down fairly simply. In order to calculate it, what you would do is build a table with 5 columns. Okay, the first column, you would list your independent variable, in this case, number of siblings. Second column, you list the dependent variable, in this case, the number of kids. Now, third column is X times Y. So you take your independent variable times your dependent. Do that for each row. Fourth column, X squared. Take your independent variable times itself for each row. And then finally, the fifth column, take your dependent variable, Y, times itself. After you've done that, for each of the 5 columns, add them up. Now, once you've done this, these 5 numbers plus n, the number of pairs of data you have, are all you need to calculate the correlation coefficient. Okay, so our formula here, and we'll start walking through putting numbers in. R equals, in the numerator we have n. N is the number of pairs. We had 6 rows in our table. Only thing there, be careful, don't count your total row. Now, sigma xy. We've seen before in this class, capital sigma means we're adding something up. We're adding up x times y. That we pull from the bottom of column 3. In the second term of the numerator, first factor is sigma x. What happens when we add up all our x's? 12, bottom of the first column. Second factor in the second term, sigma y, total from the bottom of the second column. Added up all our y's, 23. Okay, so the numerator works fairly easily. Denominator, we have to be a little bit careful. We have a couple n's in here, so we can drop the 6's in on them. But where you have to really pay attention is here we have sigma x squared 2 different ways. We have one place where the parentheses are outside, and then one place where the square is outside. Now here where we have sigma x squared and the parentheses are outside, what we want to do is we want to add up the sigma, we want to add up the x squareds. So that's the total from the bottom of row 4, x squared. In the second example, we have sigma x with the square outside. We want the total from the bottom of column 1, 12, but then we'll need to square it. We do the parallel thing with the y's. Sigma y squared, the square inside, bottom of column 5. Sigma y squared with the square outside, bottom of column 2. All right, so in the numerator, we do our multiplications first, because multiplication before subtraction. Same thing in the denominator, do our multiplication and our squarings. Then we do our subtractions inside the, well, first in the numerator and then inside the brackets or parentheses in the denominator. Do the multiplication in the denominator. Do the square root in the denominator. Finally do the division. All right, and we end up with r equals 0.916. And I mentioned earlier, the range is -1 to +1, so that's in range. That's good. Now, one of the things you want to note of with the correlation coefficient, it's positive. If you go back to this graph, when you have a positive correlation coefficient, what you should see is this line should go up from left to right. And we see that is the case.